Welcome to my new channel. Today I will discuss about the refraction of light at plane surface, which is in icse class 10th physics. Before that, this reflection chapter you have read in class 9th for plane surface and for curved surface also. Curved surface means mirror. What is reflection? Suppose you consider this is the air medium and this is the plane surface, and when the light comes from air, when it strikes on the surface and if it goes back to the same medium, see this is also air, if it goes back to the same medium, then this phenomenon is called the reflection of light, and this is called the incident ray, this is called the reflected ray, this is angle of incidence, and R is the angle of reflection. And this is plane surface, maybe mirror actually plane mirror, not curved mirror. Curved mirror means there are two types of mirror, concave and convex. This is plane mirror. Now this reflection of light obeys two laws. One is the incident ray, reflected ray, and the normal at the point of incidence are all lie at the same plane, and the second law is the angle of incidence equals to the angle of reflection. This is normal. Normal means draw the perpendicular line on the surface, this angle will be 90 degrees. And one thing the speed of light in air, V in air, equals to 3 into 10 to the power 8 meter per second, and the speed of light for water, it is 2.25 into 10 to the power 8 meter per second, and for V for glass will be 2 into 10 to the power 8 meter per second. Up to this you have learned. Now I will discuss about the refraction. What is refraction of light? So next topic is refraction of light, but before that you have to learn what is optically denser medium and what is optically rarer medium. The light travels in a straight line path in a particular medium. Suppose in a air, then it travels along a straight line path. But if the medium changes, suppose from air to one glass is there, suppose this is glass, here it is entering, so obviously the speed will decrease, or means the speed will change. When the speed will change, then the direction of light also it will change. Now come to the optically denser medium. Here suppose this is the boundary. Why I have taken the boundary? Boundary means which separates the two medium. Suppose this is medium 1, this is medium 2. So M1 and M2 I am writing. The light is falling on the surface. So light is falling on the boundary. Here I have drawn the normal. Now when the light is entering from one medium to another medium, the speed will change. It may decrease or it may increase. Suppose I have taken here the first case is the speed is decreasing. So in first case, when the speed decreases, then this will consider as the optically denser medium. So when speed decreases, then this medium will be which medium? This medium 2. This medium 2 is the optically denser medium, and when the speed decreases, then the refracted ray comes closer to the normal. So this angle is the angle I, angle of incidence, and this is the angle of refraction. Okay. In the next case, if the speed increases, then two medium again, 1 and 2, the light is falling on the surface and it is traveling from 1 to 2. If the speed increases, then this medium 2 is considered as the optically rarer medium. And now the diagram will be like this, means the refracted ray will move away from the normal. Okay. And now this angle will be R and this angle will be I. So here two topics we learned. One is optically denser, where the speed will decrease, and another is optically rarer, where the speed will increase. Now you can ask, the density, normal density and optically density is same or it is different? No. Here the density and optical density, it is different. How? Think about one example, which is oil. Okay. So in case of oil, it floats on water. Oil always floats on water. So in this case, as it is floats on water, so we can say this oil is, the density of the oil is less than the density of the water. That's why it is floating. But in case of optical density, the optical density of the oil is more than the optical density of water. Why? Because if we take two medium, one is water and another is the oil, then we will observe when the light is coming from water to oil, then the speed will decrease and the refracted ray comes closer to the normal. So we can say this is optically denser medium compared than the water. This is the difference between optically denser or optically rarer medium. So we can conclude that the optical density depends on the speed of light. If speed increases, then it will behave like a optically rarer medium. If speed decreases, then it will behave like a optically denser medium. So optical density depends on the speed of light, whereas the density of the medium depends on the intermolecular separation. Now come to the refraction topic. So what is refraction? See, before that I told, if we take two medium, when the light travels from one medium to another medium, when it is entering to another medium, means second medium, the speed will change, means it may decrease or it may increase. Suppose the speed is decreasing, that's why the refracted ray is coming closer to the normal. So this is angle of refraction and this is angle of incidence. Now this phenomenon is called the refraction. As definition we can say the direction of the change in direction of light when it is passing from one transparent medium to another transparent medium due to change in speed, that is called the refraction of light. So here this is angle of incidence, this is incident ray, this is refracted ray, and this is angle of refraction, and also there will be some part will reflect also, but maximum part will refract when it is falling on the surface of the two medium, or when it is coming from one transparent medium to another transparent medium.
Now three cases I will discuss. First one is case number 1, when the ray is coming from air, means rarer medium, to denser medium. So rarer medium I have given the air and denser medium I have given the water. Okay, R and D I am writing. Now the ray is coming from rarer medium. This is the incident ray and this is the angle of incidence. So when it is entering to the denser medium, denser means obviously optically denser medium. So in optically denser medium, what we have read, when it is entering inside the optically denser medium, the speed of the light will decrease. That's why the refracted ray will come closer to the normal. Okay, this is the refracted ray and this angle will also be R. And what is the direction of original incident ray? This one. Okay, so how much it deviates? This much it deviates. This deviation is called the angle of deviation, means the angle between original incident ray and the refracted ray is called the angle of deviation. But if we want to calculate the value of delta, how will you calculate? See, as this angle is I, so this total angle will also be I because of vertically opposite angle. Now clearly we can say this angle I is greater than the angle R. Okay, so delta will be I minus R. This is the first case. Now come to the second case. Case number 2, the ray is moving from denser medium to rarer medium. So this is denser medium D I am giving and rarer medium air R I am giving. Okay, this is the normal and the ray is coming from denser to rarer medium. this is angle of incidence. Now what will happen? See, in optical density part, I told in a rarer medium the speed of the light will increase. So when the speed of the light increases, the light will bend away from the normal. This is the direction of refracted ray. And what was the original incident ray path? This is. So how much it deviates? This much. This value is delta. And what is the value of r from the normal to the incident to the refracted ray? This value is the r. And see, clearly we can say if this is I, so this angle will also be I. This angle will be I. So what about the value of delta? So delta equals to, we can write r minus I. Okay, and clearly you can say this r is greater than the angle I. This is the second case. Okay.
But in every cases, I have drawn here the light, when the light comes from air to rarer to denser medium or denser to rarer medium, the speed of light will change. That's why the light will bend away or towards. But there will be some reflection also. Means some part will reflect and some part will refract. That I have shown here. Now, what about in the third case, case number 3? See. Now, if the light falls normally means this angle will be 90 degree, means the angle between incident ray and the surface will be 90 degree. Then what will happen? First I am drawing, then I am explaining. It will not change the direction, means it undeviates its path. It retraces its path. So here, if angle equals to angle of incidence is 0, so angle of refraction will be 0. Why? That also I will explain. See why it does not change its direction. Now in next class I will tell about the loss of refraction, where the second law is sin I divided by sin R equals to the constant which is called the refractive index. That also I will explain, but for explanation I am telling this one. This is mu and this is equals to the V1 by V2, where V1 is the velocity in first medium and V2 is the velocity in second medium. So from here, see, I will be 0. We just forgot about this part. What about the value of angle of refraction? That I will calculate from this equation. So put it. So by cross multiplication, V2 sin I equals to V1 sin R. Okay. Now sin I is 0. So this is V2 into 0, sin I 0, and V1 into sin R. Okay, now see, here this part is the 0, but V1 itself is not 0. Why not 0? Because suppose it is denser medium or rarer medium, whatever. Suppose it is rarer medium, air. So there will be some speed. V1 itself, it is not 0. It is not possible. So sin R will be 0. When sin R will be 0, the angle R will also be 0. This is the explanation. So R means 0 means what? It will not change its direction. But see, one thing the question may arise, is this the case of refraction? Obviously this is the case of refraction. This is also the refraction. Why? Because here suppose air, it is water, rarer to denser or denser to rarer, whatever. The medium is changing, but the direction is not changing. When the medium is changing, then the case we can say this is the refraction. And here one thing also we can say, the velocity of light when it is entering to the second medium, means water, the magnitude of velocity will change, but the direction will not change. Okay, the magnitude of velocity will change when it is entering, when it is passing through water, but the direction does not change, but the magnitude will change. Okay, and how this R came, that I have explained from the Snell's law of refraction. Now the topic is the cause of refraction. Why the refraction occurs? Now see, when the light is coming from rarer to denser or denser to rarer, there is a bending. It may bend towards the normal or it may bend away from the normal. So when towards the normal means the speed decreases, away from the normal means speed increases. So why the refraction occurs? Tell. The refraction occurs due to the change in speed. If the speed changes, if the speed decreases, then it will come closer to the normal. If the speed increases, then it will move away from the normal. So the refraction occurs due to the change in speed. To discuss up to this, next day you will get the topic laws of refraction.